Yeah, hello. I presume you can hear me now. Should be able to. Should be live. Welcome to people that are joining this morning. And also to the people that are going to watch this back later on and have a look at this. I'm going to be going through, basically, like I put in the title this morning, the formula sheets for Foundation, Higher, Edexcel, AQA, iGCSE, and looking at actually what's on them. First of all, what don't you need to remember, but also how to use them, because sometimes they can be laid out in unusual ways, let's say, which you'll be unfamiliar with if you haven't looked at the formula sheet previously. But we'll go through that shortly. For the moment, while people are joining, if you have a look at and have a go at maybe these first 10 questions just to get warmed up, have a think about what they are at least, or how to do them. And thank you already as well to the people liking the videos, because that helps. Let me know that actually these are useful and appreciated and worthwhile doing, whether that's watching it live now or afterwards. So I'll give us another couple of minutes just to let people join and for people to have a think about these first 10 questions just as a warm-up. And again, these are from MathSpot. These are called 1-mark wonders. It's just some relatively straightforward. Hopefully you can change the difficulties, you can make them more difficult, but these are questions which would generally be 1-mark questions because there's only one thing you have to do. If you haven't already looked at or seen the formula sheets, definitely recommend, if you're not going to stick around or can't stick around to watch the rest of this video, maybe watch this video back or have a look at them yourself first of all, and make sure when you're doing your practice papers, when you're doing your revision, you do have it to hand and you are referring to it and using it when you need to. You might not need to at all, but things like area of a trapezium, you might think, oh, I can't quite remember that formula, so it's on the sheet, I know that, I remember that. Circumference and area of a circle, volume of a prism. There's quite a few shape related formulas on there, or formulae I should say. There's also all the trig stuff, so Pythagoras, trig, compound interest, probability, all of those things are on there. Okay, one more minute and then I will go through these questions and then we'll start talking about and actually looking at these formula sheets, what's on them, and then practicing some of these questions. Now, for the main part of this, the foundation questions, they are the ones that require the formula sheet. They're the second half of the paper, so that would be what's called generally the crossover questions. So they will be on the end of the foundation, the start of the higher paper. So all these questions, like usual, are applicable to foundation and higher papers, and again there's a mix of where those questions are from, because there are some slight differences between Edexcel and iGCSE. Edexcel and AQA are pretty much the same. I think they're almost exactly the same, if not exactly the same, whereas iGCSE has a few different ones on there. There's a few less and a few more in terms of different ones. Okay, right, so I'll go through these questions and then I'll stop talking about these formula sheets so we can actually have a look at them. So first question here, solve 2 is equal to something divided by 6. Now what you can do is you can think about it as something divided by 6 is 2. That's a quick way of doing it because there's actually only one thing that we're going to have to undo here. What we're going to have to undo is this divide by 6. So times by 6 on both sides, if you can't think of the number. 2 times by 6 is 12. So x is equal to 12. The next one is finding the median. Now, the first thing you need to do when you're finding the median is put your numbers in order. So, lowest number first, although having said that, it doesn't matter whether you go lowest to highest or highest to lowest, because you're finding the middle number anyway, and it's not going to change that. Cross the 4 out so I don't use it again. 6 is next, and then 7, 9, 12, and 16. And from there we need to basically find out where the middle number is, and there's a couple of ways you can do that. You can use this method, which I'll show you now, of finding the position of the median. Now this I wouldn't do in this case because there's only a few numbers, so I'm going to use the second method I'll show you, but you do need to know how to locate the position of the median for other questions. So it's always useful as a reminder, but also, to check your answer as well, because both methods should find the same answer. So I've got 1, 2, 3, 4, 5, 6 numbers. So the position of the median will be halfway through that, and actually it ends up being 6. Add 1 and then you half it. You don't just do half of 6. Now you'll see why that works if you look at 3 numbers. The middle number is the second one. So you add 1 to 3 and half it. 3 add 1 is 4, half that is 2, so you get the second position. And you can build it up and use 5 numbers and 7 numbers, and you will see that the middle number is in this position. You do add 1 to it and then half it. 6 add 1 is 7, half of it is 3.5. Now that means the 3.5th position. That doesn't mean that your median is 3.5, obviously, because 3.5 is lower than our lowest value, which is 4, so how could that be in the middle? Okay, that's the position. So 1, 2, 3, 0.5 is halfway between my third number and my fourth number, so it's in the middle here. Halfway between 7 and 9 is 8. So median is 8. Now say you have some numbers in the middle, well, say you have some numbers here, not 7 and 9, which are more difficult to work out the middle value of, then what you essentially do is you work out the mean of those two numbers. So for instance, you do 7, add 9, and then half it. That's the median. You add your two numbers up and then divide by how many numbers you've got. 7 add 9 and half it. 7 add 9 is 16, half of that is 8. Okay, so my median is 8. Now the other method, which I would have used for this because there's only very few numbers, is actually crossing them off at either end until you get to the middle number. Now when you do this, in your head, obviously, not in the exam hall out loud, I would strongly suggest saying 1, 2, 1, 2 in your head, because you don't want to lose track, especially if you've got 10 or more numbers. It can be a bit difficult to know exactly that you've done it right, unless obviously you use this other method to check. So cross them out. 1, 2, 1, 2, 1, 2. Then I've got this number in the middle, or I could have looked at that 7 and 9 and gone, well, it's got to be between those two, because there's two numbers in the middle. And that's how you do it. Okay, and you still get in the middle of 7 and 9 is 8. Okay, next question. It doesn't tell us what to do here, but it's quite obvious we've got to work out this next number in this sequence. So all we really need to do is look at what's happening in this pattern, in this sequence, and we're taking away 3 each time, subtracting 3. So 15 take away 3 is 12. 25%. Now I know 25% is 1/4. That's one of those things that last time I said you have to just know, have to remember, and they would expect you to know that. So 1/4 of 20, well, that's 20 divided by 4, which is going to give me 5. Next question, we've got -5 add +5. This is one of those where it's very straightforward. -5 add +5, and in the MathSpot questions, because it's just automatically generating them, there will be some easier ones, some trickier ones. that's just the way it's going to be. But like I say, you can change the difficulty for this. This is only about, I suppose, 3 out of 10 in terms of difficulty. -5 out of +5 is going to give me a sum of 0. Each negative will cancel out with a positive. You have those what I call 0 pairs. Okay, a -1 and a +1 is a 0 pair, and there's 5 of them. -5 add +5. Now this is an interesting question, and one which probably quite a few people will be unfamiliar with. 130 centilitres. Well, how many centilitres are in a litre? Now think of the prefix cent. How many years in a century? 100. How many centimetres in a metre? 100. How many centilitres in a litre? 100. And you can kind of compare this to, centimetres and millimetres. How many millilitres would you expect there to be in a centilitre? Or how many millimetres are in a centimetre? There's 10. So this follows that same rule. Okay, there's 10 millilitres in a centilitre. So there's going to be 130 times by 10 to convert it into millilitres. We get 1,300 millilitres. When you're looking at units, think about the prefixes and what those mean, because they will be common throughout different units. 14th multiple of 5, we need to do 14 times 5. Multiples are your times tables, essentially. So that's the 14th number in my 5 times table. 14 times by 5 is going to give me 70. Simplify 10 over 15. I need to find a number I can divide 10 by and divide 15 by. 5 goes into both of them, so divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So my answer is 2/3. Next question, write 0.4 as a percentage. Now to get from decimals to percentages, you've got to times by 100. So 0.4 times by 100 is going to give me 40%. How many sides does a trapezium have? Best way probably to think about this question is to draw one, or sketch one at least. But it's fairly straightforward. A trapezium is going to have, these sides should be parallel for a trapezium, 1, 2, 3, 4 sides. Okay, so 4 sides to a trapezium, so quadrilateral. I'll leave those questions go, and what we're going to look at now is the formula sheets. So as you can see there, we've got the formula for the area of a trapezium. It says here A and B are the lengths of the parallel sides. So the sum of the parallel sides, half of it, and then times the height between them. If there's no gap between a number and a letter, we know that means you need to multiply them. So we've got a half times by A plus B times by the height. And the height is their perpendicular separation. That's the distance between your parallel sides, but it's got to be perpendicular. Volume of a prism is the area of a cross section times by the length. Now, one difference between this and the IGCSE formula sheet is that on the IGCSE one they have the formula for the volume of a cylinder. This doesn't have the formula for the volume of a cylinder, but it works in exactly the same way as the volume of a prism. It's the area of the cross section times by the length or the height, depending on the orientation. So although it's not on there, but it's on IGCSE, you can still use this volume of a prism formula, and that will work exactly the same way. It will work out the answer. R is the radius and D is the diameter. That should be fairly common because that's what we use when we're learning about circumference and area of a circle. Circumference is 2 pi r or pi d because your diameter is 2 times your radius. So that's the circumference of the circle, and then you've also got area of a circle is pi r squared. So that's really useful because sometimes people can get mixed up and confused with those two, which one's which. A good way to remember is area is units squared, so you've got to do pi r squared. Okay, circumference is a distance around your circle, so your power, if you like, of r is 1 because you know, it's centimeters, millimeters, kilometers, whatever your units are, is to the power of 1. Now, what I mean when I say that is there isn't a power. If there isn't a power, that means the power is 1. The next thing we've got is Pythagoras theorem and trigonometry. Now, they've labelled this triangle, I would say, in the usual way for Pythagoras. So A, B and C, doesn't matter which way around they are. In any right angled triangle where A, B and C are the length of the sides and C is the hypotenuse, A squared plus B squared is C squared. Now, what you have to remember with that is to work out this hypotenuse, you need to square root it. So C is actually going to be A squared plus B squared, and then you square root it. With B, you've got to subtract. So we're going to do C squared, your longest side, your hypotenuse, take away A squared, and then you square root it. You essentially rearrange this formula. And for A, we've got the square root of C squared take away B squared. And that's how you do your Pythagoras theorem. Now, for the next bit, we've got trigonometry in right angled triangles, that is. So in any right angled triangle ABC, where A, B and C are the length of the sides and C is the hypotenuse, sine of A, now they've placed or they've chosen where this angle is going to be. They're going to have to do that so they can give you this equation, but that is going to impact upon what your triangle looks like and where you're using this on your question, because you might have your angle as being up here, in which case it's going to change what these formulae are. So you have to really, to use these trig formulae, you need to actually know. You can't just look at that and use it. It's very, very unlikely, unless you have the exact same triangle as this. You would have to have seen trig before, obviously, and know what you're doing. So although this is only very slightly helpful in the fact that you can use this to remember SOHCAHTOA, which is what people usually remember. So I'll write that down. People usually remember SOHCAHTOA. Now I write it like this because that basically tells me all of this. So sine is opposite over hypotenuse. So opposite is A over the hypotenuse C, A over C, which is how you get that. But this is not predefined by a particular angle. We basically define what is opposite, adjacent, hypotenuse in reference to the angle which we've got. But that's all this is. It's just got A, B's and C's in there already and can be a little bit more confusing. So I would recommend really, not leaning on the formula sheet for trigonometry. I would make sure that you know SOHCAHTOA, so that you remember this, but then also you need to know how to label your triangle. So if we're looking at this angle A here, then A would be the opposite because it's opposite your angle. C would be the hypotenuse because it's opposite the right angle, and then B would be the adjacent because it's next to the angle but it's not the hypotenuse. And that's where the O, H and A come from, and obviously you need to be able to use that. Next thing on here is compound interest. Now this is another formula which isn't in the usual way, and so that's one which definitely would need to practice if you did want to use this formula. Okay, so you could remember it the other way. Compound interest is not one. Getting confused by this one here. It's the original amount times by the multiplier, and then you've got however many times it was compounded. So n is the number of times the interest is compounded, so to the power of n, where n is the same way they've defined it up here. The confusing bit is basically they don't have a times in between, which they shouldn't do because it's algebra, but you need to know there's a times between there. And also this bit, you need to know that that's your multiplier. That's what that represents. It can be easier if you know what you're doing with it, which I'll show you, but it can be tricky if you haven't seen it before, and you can get confused and use it in the wrong way. Now the next bit here is probability, and actually these probabilities, in terms of this, probability of A or B, this isn't, I wouldn't say this is not the most useful in the way it's written down. So much more useful way, and maybe more familiar way to see this is A or B is written as A union B. That is equal to the probability of A plus the probability of B minus, or A and B is the intersection, so probability of A intersect B. That is the more common way of seeing that. And actually, having looked through, I've got to say, probably about 30-40 exam papers that were available, Edexcel, AQA, IGCSE, I could not find a scenario where it actually required you to use this. I'll show you what I mean when we look at some questions. I'll show you the common types of questions, and the reason you don't end up using this is because in all the scenarios that I could find looking at the papers from like the last 10 years, AQA, Edexcel, IGCSE, this intersection, when you could use this formula, was 0, but I'll show you that when we come to it. This is most useful when you're looking at Venn diagrams. So if you had a Venn diagram, I'll just sketch one out for us. A union B means, let's call this A, this B. We'll put some probabilities on there. So let's make this 0.1. Let's make this 0.3. We'll make this 0.4. And then we've got 0.3, add 0.1 is 0.4, add 0.4 is 0.8. So that has to be 0.2 outside. And I should put my symbol for the universal set. That just means we've got everything in there. This is everything. Now what this means is probability of A or B is actually probability of A, so that would be probability of A is the whole A circle. So probability of A, I'll write that down first of all, is 0.4, 0.3 and 0.1. Probability of B is 0.4 add 0.1, so that's 0.5. Probability of A intersection B is the middle, which is 0.1. And so what this formula says is that A or B, probability of A union B, is the probability of A, so 0.4, add 0.5, subtract the probability that both happen at the same time. So the probability that both happen at the same time is 0.1, the intersection is 0.1. And what we get is 0.4 add 0.5 is 0.9, take away 0.1 is 0.8, which if you have a look at it, all we've got to do is add these up. 0.3 add 0.1, 0.4, add 0.4 is 0.8. So it gets us the same thing. What I would recommend doing, usually with questions, all probability questions, is doing diagrams. So that's either Venn diagrams, tree diagrams, you could do two-way tables, but being confident with those diagrams will, as well as algebra for your grade 9 questions, will make everything, every probability question pretty much, apart from the really difficult ones, accessible. But it will definitely make, even those very difficult ones, give yourself a way into it and a way to start it, and then it's just about the algebra and trying to find the trick, or if you like, in the question. Yeah, okay, but this isn't used very much at all. I couldn't find any examples of it in all the papers I looked at, and I must have looked at about 40-50. Now the higher, as you can see, what we've got on here, the formula sheet for perimeter, area and volume is exactly the same. You do get extra the quadratic formula, which is given to you, which is nice. Pythagoras theorem and trigonometry. Okay, we've got this, so A, B and C, exactly the same things. We've also got sine rule, cosine rule, and the area of a triangle. So this is trigonometry that is not for right angle triangles. So sine rule, this should be familiar, cosine rule should be familiar, area of a triangle should be familiar. The only thing that isn't on there, which you might have to work out from the cosine rule, is the formula for the angle. So the angle here is A, okay, well this is A here. You'd have to rearrange that. So A squared minus B squared minus C squared divided by negative 2bc, and then you've got to inverse cos all of it. I will go through one of those questions and show you how to do that again if you need a reminder. Compound interest is exactly the same. Probability, the only difference is you have probability of A and B. It's probability A given B times by the probability of B. Now again, another way you might see that written is probability of A intersection B is probability of A given B times by the probability of B. Now A given B is A line B. That's another way you might see it written. You might need to rearrange this, so you might have to use the fact that probability of A given B is probability of A intersection B over probability of B. Now again, I couldn't find anything which would require you exactly to use that formula, and actually the best way of doing questions like that is by using diagrams and looking at the diagrams and understanding those Venn diagrams. So if it says given, it's in B, then your denominator on your fraction is just out of the total of B. So the best way for probability questions, I would suggest, is not using these formulas. It's understanding, practicing the diagrams, Venn diagrams, two-way tables, tree diagrams, and really understanding those and how those work. And there will be some conditional probabilities in those, which is what this is. This is a conditional probability down here. So yeah, practice those, and towards the end of those, you know, use Maths Genie, the questions on there. Towards the end of those questions, the harder questions, will be some conditional probability questions. Okay, now I'll show you quickly the similarities between Edexcel and AQA. Now, if you have a look here, this is really, for all intents and purposes, the same thing. So you've got all your perimeter area and volume, you've got Pythagoras and trig, exactly the same way laid out, compound interest and probability exactly the same. Now, on the higher, as we would expect, that's exactly the same as well. So you get everything on here that you get on Edexcel, and then GCSE, we get this. So this is obviously looks different, but is also different in terms of what you get. So you get the area of a trapezium, you get the volume of a prism, you get the volume and curved surface area of a cylinder. So that's something that you don't get on Edexcel or AQA. What you also don't have on here is, if we have a look, you don't get Pythagoras theorem and trigonometry. That's not on there. You don't get compound interest, and you don't get a probability formula. So it's all shape related. Now the higher, we do get very similar. So you see up here, arithmetic series. Now that is something which is not on AQA or Edexcel, and that's the sum. So this is the sum of basically a sequence. So if I was to do the Fibonacci sequence and added up the first 10 terms, but this formula won't work because it's got to be arithmetic, and Fibonacci is not arithmetic. So arithmetic means a sequence is going up or down by the same amount each time. So if I wanted to add up the first 10 numbers in that sequence, I would do S10 and plug in 10 here. A is your first term and D is the difference. Quadratic formula again, area of a trapezium again. Trigonometry, we don't get Pythagoras theorem, and we don't get right angle triangled trigonometry. So you don't get SOHCAHTOA essentially. You have, you know, a standard, or not standard, a non-right angle triangle I should say, trigonometry. So sine rule, cosine rule, again not rearranged, just the standard cosine rule, and the area of a triangle, half AB sine C. You do get additionally volume of a cone and curved surface area of a cone. However, I will say usually on the test these will be included with the questions that you need to use it for, usually. If it's on Edexcel or AQA, so that will be next to it. It won't be on the formula sheet, but they'll have it next to the question. And that's the same with the volume and surface area of a sphere. That they will also put that next to the question if you need it for the question, usually. Volume of a cylinder, that's the same as volume of a prism, which we spoke about earlier, but they also have the curved surface area of a cylinder. They don't usually give you this as far as I remember or know. That's something you have to work out by drawing the net of your cylinder. So net of your cylinder, 2 circles, and then we've got to do the area. The area of the circles are easy, pi r squared. The area of the rectangle, which is h, which is the height of your cylinder, times by the width. The width is going to be the circumference of the circle, because this rectangle wraps around your circle. So it's going to be pi times your diameter, or 2 pi r h. It tells you here curved surface area of the cylinder. So 2 pi r h to work that bit out. Excuse me. Not the h, excuse me, because that's when you times it by here. 2 pi r is the circumference, times by h gives you the area of the rectangle, and then each circle is pi r squared, which is at the top of your formula sheet. Okay, so there are a few differences, but actually some of the differences you do get on Edexcel and AQA, just next to the questions. The curved surface area you don't get, you have to remember that or work it out. And then the arithmetic series obviously is not on Edexcel or AQA, so you don't get that, you don't need it. Okay, questions to have a look at now, and what I will try and do when I'm going through this is refer to the formula sheets throughout to show you actually where I'm using it on these questions. And I will make sure before the end that I come back to that question that I put in the thumbnail to go through. Right, John is going to paint the floor. This is, sorry, I should read the start of the question, always do that. The diagram shows a floor in the shape of a trapezium. John is going to paint the floor. First thing I'm going to do before I read the rest of this question is work out the area of this trapezium. So I can use my formula sheet. Area of a trapezium is half of a plus b times by the h, times by the height h. A and b are the lengths of the parallel sides. That means they're going in the same direction. So parallel sides are these two. So I need to do 10 add 16 and then half it, and then times by h, which is the perpendicular separation, so the distance between, so times by 7. Now I can't remember whether these were calculator and non-calculator questions, so I'm going to use the calculator, but obviously if you had to do it without your calculator, then you just have to do your written calculations. This is actually not too bad to work out, because essentially half of this sum is going to do halfway between 10 and 16, which is going to give me 13. 10 add 16 is 26, half is 13, so we get 13 times by 7. 7 times 3 is 21, 7 times by 10 is 70, so we get 91. Units are meters squared, so 91. I'd always recommend writing areas inside, because that's what the area is, it's the space inside. Each 5 litre tin of paint costs £16.99. 1 litre of paint covers 2 meters squared. John has £160 to spend on paint. Has John got enough money to buy all the paint he needs? Now 1 litre of paint covers 2 meters squared, so we need to do 91 divided by 2. And we're going to get 45.5. So that means he needs 45.5 litres of paint. So I'm just going to put an arrow here. 46 litres of paint needed. I mean technically 45.5, but it's over 45. And he can only buy 5 litre tins. Or you could say 45.5. I've only rounded it up because we need a whole number of tins, and really actually I could work out. This is 40, yeah, 1 metre of paint covers an area of 2 metres squared. So we've got, how many 2 metres squared are in that? That's 45.5 2 metres squared. So that's 1 litre of paint for each of those. So we need 45.6 litres, 45.5 litres or 46 litres. So 45.5 divided by 5 is going to be 9 point something. 45.5 divided by 5 is 9.1. I am going to change this actually. 45.5 litres of paint needed. 9.1 tins needed. So that means he has to buy 10 tins. Uh, 10 times 16.99 is going to give £169.90p. Has John got enough money to buy all the paint he needs? No. You must show how you got your answer. I have. Okay. Trapezium is something that people can forget as well. It's one of those things people do forget. So, you know, remember that it's on the formula sheet and then know how to use that. You don't have to then remember it. Next question, triangular prism. Work out the volume of the prism. Now, without realising it, I was just thinking this was a straightforward volume question. This actually requires two things that we've got to do, two formulas. Now, if you notice, this 8.4, that's the diagonal here, that's the hypotenuse. Okay, and 7.2 is the height. We need to work out the area of this triangle here. To do that, we need to do the base times the perpendicular height, and then half it. We don't know what the base is, but as it's a right angled triangle, you can use trigonometry. So I'm going to use my formula sheet again. I need to work out this bottom value here, B if you like. It looks slightly different, the triangle, but it's still this bottom side next to my right angle here. So B, I said c squared minus a squared. I've got to rearrange this and then you square root it. So basically you square both sides, take them away from each other and square root it. You only add them if you're working out the hypotenuse, which is the longer side. 8.4 squared, take away 7.2 squared, and then you square root it, and that will give us our answer. So square root of 8.4 squared minus 7.2 squared, and I get this not particularly nice number, which is 6 root 13 over 5, which is 4.3. Now I'm going to leave that as a surd, and the reason why is because that's the exact answer. If I write this down and I round it, I'm going to get my answer at the end very slightly wrong because I'll get a rounding error. So I'm going to write this as 6 root 13 over 5, the exact answer. Next part of the question, so that is 6 root 13 over 5. Now I can do base times height, half it times 18. So I'm going to do 7.2 times by my answer in my calculator. You can just use the answer button, and then I'm going to half it. Okay, so fraction 7.2 times by answer button, which is 6 root 13 over 5, divided by 2. Your calculator won't round it, so if I use answer, that's fine. And I get this answer, which is 15.5759. Now I can't press S to D and change that to an exact answer. I'm going to have to write this down, but what I'm going to do, I'm going to keep it on my calculator. Another way as a fail-safe to make sure you don't get any rounding errors is write the whole answer that your calculator gets down, all the digits. Then we need to do this answer, 15.57598151 times by the depth, which is 18. And that will get us our final answer. Notice there how I didn't just times this by 18, because that mathematically isn't correct. I can't just have one calculation, get my answer, and then times that by 18, because then this side of the equals is not the same as this side of the equals. You can't just write maths down left to right continuously. You need to kind of break it up and say, you know, step by step what you're doing. So I think of maths generally as more bullet points rather than, you know, writing an essay. So this answer times by 18, 280.367, I've got to round it to 3 significant figures, so 3 significant figures, 1, 2, 3. Look after the 0, it's a 3, so that's going to stay as it is, 280. That is units centimetres cubed. Okay, next question. So that's used Pythagoras, and well, it hasn't used. It's used volume of a prism. So volume of a prism, I'll show us again, is area of the cross section. So you've got to do the area of the triangle, which is what we did here. 15.57 dot dot dot. And then when you've got the area of your cross section, you times it by the length or the depth, depending on how you're thinking about it. Times it by the 18. Next questions to have a look at. Hazmeet walks once around a circle with diameter 80 meters. Now, again, like I always do, if it says something that's not on the diagram, put it on the diagram. So you could put your diameter, or I'm going to put the radius. I'm going to put the radius, which would be half of that, which is 40. There are 8 points equally spaced on the circumference of the circle. Okay, now it's talking about circumference. I know with circumference I need the diameter, so I am going to put on the circumference. I'm just going to put it on the other way. So that is 80. Find the distance Hazmeet walks between one point and the next point. It says they're equally spaced. So if I work out the circumference and then divide it by 8, that will split it up into 8 sections equally. Right, circumference of the circle. I'm sure that's on my formula sheet. It is. Circumference of the circle is 2 pi r, or pi times by diameter. So pi times by the diameter is going to give me 80 pi. That's an exact answer. I haven't put it in my calculator and got the decimal. If you can leave things as exact answers, do that, because that will make your life easier and it will make your answer not have a rounding error. So 80 pi, that's the full circumference. And also one thing is, it's always helpful to put kind of like notes down to tell yourself what you've worked out, but also it's going to reduce the amount of errors you're going to make, because you're going to know what the number is. What does that represent? Well, that's the circumference of the circle. Now I need to divide that by 8, so 80 pi divided by 8, 80 divided by 8 is 10. So 10 pi. Units I need, that's meters, so this is going to be meters. It's the distance between one of these, or two of these letters. So 10 pi meters. Pi is not a unit, meters in this case are the units. Pi is a number. Next question. 4 of the points are moved as shown in the diagram below. Hazmeet walks once around the circle again. Has the mean distance that Hazmeet walks around the point, walks between one point and the next point changed? You must give a reason for your answer. Now for this question we've got to think about how the mean works. Now the mean is adding up all of your numbers and dividing by how many there are. So if I think about these distances, because that's what I'd be adding up if I'm working out the mean of the distances. I'm adding up all the distances. If I add up all these distances, so this one, add 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 this one. Adding all of them up, I'm going to get the same total. So I'm still going to get 80 pi. If I add them all up, that's still the same total, and I'm still going to divide it by 8 because we're looking at the mean distance. That's the average. The mean is one of the averages. That's an average distance. So although, you know, the distance between H and A is bigger than the distance between, smaller than the distance between G and H, the average distance will be the same because the total is the same. So has the mean distance, he walks between one point and the next point, changed? No, the mean distance hasn't changed. As the total distance of all 8 points hasn't changed. And we're still dividing it by 8, so it's going to stay the same. Next question. this is looking at a sector of a circle. It's this is the type of question they're going to give you with area of a circle. I would think if you do get one, it wouldn't just be work out the area of the circle. Generally speaking. So we're going to use the formula for area of a circle, but then we've got a bit of problem solving in there as well. The diagram shows a sector OPQR, OPQR, centre O and radius 8. OPR is a triangle, so OPR is a triangle. Work out the area of this shaded segment. Give your answer to 3 significant figures, so we're going to have to round it again. Now, with this, all of these formulas, so all of the bits that we need to do this are on the foundation tier formula sheet. So actually this could be on a foundation paper question, could also be on a higher paper. Okay, so I need the area of a circle first of all, because I'm looking at area and this is part of a circle. You're probably shouting at the computer right now. Actually, that's a quarter of a circle. It isn't a full circle, and you're right, because it's got the right angle in there. That means it's a quarter of a circle. So we've got to find the area of the full circle and then divide it by 4 or times it by a quarter to get the area of this sector. So area of a circle is pi r squared here. So we need to do pi times by r is your radius. Now this is my radius here because it's going from my centre to the edge of my circle. Pi times 8 squared. That gives me the area of the circle, which is 64 pi. Now then, like we've just said, that is the quarter of a circle, so we need to divide it by 4. 64 pi divided by 4, half of 64 is 32, half of it again is 16 pi. So the whole thing is 16 pi. Now, we need to take away, because we just want this shaded area, the area of this triangle. Now the area of the triangle is going to be 8 times 8 and half it. 8 times 8 is 64. 64 divided by 2 is 32. So that's 32 centimetres squared. So that is area of the triangle. Area of sector. So we need to take these away, so we need to do 16 pi, take away 32, and that will give us our answer. And to 3 significant figures, 1, 8, 2, look after the 2, it's a 6, so that makes the 2 go up. 5 or above makes the previous number go up, so 2 goes up to 18.3. And the units there are centimetres squared, its area. Okay, now what I'm going to do, because of time, we've only got about 12 minutes left after looking through these formula sheets. I'm going to pick a few questions which will be useful for higher foundation, basically the crossover questions. So I'm not going to have time to do all of these, and I might pick one of the ones towards the end. I'm going to pick actually the ones which it's most useful for, and compound interest, you need to practice that if you're going to use this formula. This is not something you can just pick up and use straight away. At least most people won't be able to, because you won't be able to interpret what these mean, and it's not the way you will have been taught, I expect. We'll go through compound interest, and what I'm going to look at as well is this arithmetic series one, because that is quite different to everything else. And then if we've got time, I will look at some other types of questions as well, but I want to make sure we look at those ones definitely. And then these other questions, what I'll do is I'll go through those again in next week's session. Okay, so the second half of this page here is a compound interest question. It even says compound interest in the question. Sometimes it won't. If it's talking about money, then it will say compound interest in the question. If it's not talking about money, so if it's talking about repeated change, then it will not say it in the question. It's compound. So for instance, I remember a question where it said this person drops a ball, and each time the ball is bouncing to 80% of the original height. sorry, 80% of the previous height. And so essentially you're multiplying by 0.8 each time, and it's going to be 80% of the previous, so it's going to be compounded. So, you know, in certain circumstances like that, it won't say compound interest, but you're going to have to think about, is it happening to the original amount, or is it happening to the previous amount? If it's happening to the previous amount, it's compound interest. Okay, Chen invests 40,000 yuan in a fixed term bond for 3 years. The fixed term bond pays compound interest at a rate of 3.5% each year. So that's important, that's the rate. Work out the value of Chen's investment at the end of 3 years, and it pays it each year. That's important as well. So 3 years, it's going to compound 3 times. N is going to be 3. So if I get the formula sheet, now this is the compound interest here. So P is the principal amount, and that means the original amount. So the original amount is 40,000 yuan. And we're going to times that, because then we've got the bracket 1 plus R, that's our rate. Our rate is 3.5%. So our rate is 3.5 over 100, close bracket, and we've got the power of N. N, we saw earlier, is 3 years. So this will work it out. What I've got to say is actually, if you have a decreasing compound change problem, then R has to be negative. So if it's, you know, say you're looking at depreciation of a car, for instance, then R would have to be negative. If the car loses 20% of its value each year, then R would be minus 20 or negative 20. And then it would work exactly the same way. Now, bear in mind as well, this works out the total value of Chen's investment. This works out the total value. This doesn't just work out the interest. To work out the interest, you could use this formula and then take away the original amount, take away the 40,000. 40,000 in my calculator times by brackets 1 plus fraction 3.5 over 100, all to the power of 3. And that gives 44,348.72, because we've got to do the nearest, the nearest one. This is basically the nearest nearest whole number. So 44,349 would be the answer. Wang invested P1. The value of his investment decreased by 6.5% each year. At the end of the first year, the value of Wang's investment was 30,481 yuan. Work out the value of P. So this we're going to have to use the formula for, and then substitute what we do know in, and then rearrange it. So we don't know P. P is the principal amount. We do know what the answer is, so we know it's equal to, at the end of the first year, so that's N is 1. Value of his investment decreased by 6.5% each year, so R is negative 6.5, and the answer is 30,481. So we don't know P, we've got times 1 plus, and then our rate, which is negative 6.5 over 100 to the power of 1. Now we can work out this bracket. P times by, now calculator, 1 plus fraction negative 6.5 over 100 to the power of 1, and I get 0.935. That's equal to 30,481, and then I'm going to rearrange this. I'm going to divide both sides by 0.935 to undo this times by 0.935. That gives me P is equal to, calculator, 30,481 divided by 0.935, 32,600. And that's my answer. Okay, so all we had to do there is use that formula, but it's knowing how to use it, because that looks different when you're working out the multiplier. This is what you could do in your head quite often, or the way I would work it out is 100 add 3.5, So 103.5 is my total percentage, divided by 100, 1.035. That's the way I would work it out in my head. But this formula will do it for you. You just got to substitute in your value of R. Okay, the next question I wanted to have a look at is the sum to n terms. Now I'll just quickly go through, just show you actually, these probability questions. So it says find the probability that the bead is yellow or blue. Okay, I haven't read the rest of the question, but actually this isn't too important. You're choosing at random a bead from the jar, yellow or blue. Now obviously, like I said earlier, you can't have yellow and blue. Okay, so this bit here is 0. You can't pick out a bead and it be yellow and blue. That's impossible. So you have to take that. That's 0. So essentially, all you do is probability of A plus probability of B. Okay, and that's the same really for all of these types of questions they give us. So this one as well here, we've got number on tiles, and we've got how many tiles with those numbers on. Work out the probability that Carmen takes a tile with a number 0 or the number 1, and Pablo takes a tile with a number greater than 1. Okay, so part of that question is number 0 or number 1. Well, it can't have a number 0 on it and a number 1. So you're just going to add the two probabilities together. You don't need to take away the intersection. You don't need to take away the probability that it's a 0 and a 1, because that can't happen. And then down here as well, we've got a box contains 20 nails, and this is the number of nails with each length. Find the probability that the length of the nail he takes is 50 millimeters or 60 millimeters. Well, it can't be 50 millimeters and 60 millimeters. So again, with this formula, that's 0. So you just add the probability of A, add the probability of B, taking away 0. It can't be 50 millimeters and 60 millimeters. So that formula there isn't really used, not that I could find, like I said earlier, at all. So it's not one that I think, you know, from looking at how many tests I've looked at, I don't think you would have to use it at all, would be my expectation. Of course, you know, they could put something on there now that uses it, so I can't be 100% certain, but from looking at previous tests, it wasn't really used or necessary. Okay. Now I did want to have a look at the summation formula. So these other questions I will keep till next time and carry on going through those next week. Okay, so it's this top question here. An arithmetic series has first term A and common difference D. Ah, that's good, because that's what they've given me here in this arithmetic series formula. The sum of the first two n terms. So that's the sum, or S, of 2n. This is the sum to n, we need the sum to 2n. Is 4 times, so is 4 times the sum of the first n terms, so that's S of n. Find an expression for A in terms of D, show you're working clearly. Now, I've basically written down here what this says in terms of maths. Now I need to substitute in these formulas using the formula sheet. So S of 2n, all I'm going to do is change n for 2n in this formula. So I get 2n over 2, bracket 2a plus bracket 2n minus 1d. That's equal to 4 times, this is just S of n, so n over 2, bracket 2a plus n minus 1d. Now all I need to do is expand that out and sort it out, rearrange it, so I get, you know, a is equal to some function of d. So 2n over 2 is going to give me n, bracket 2a plus, now I can expand this out, so 2nd minus d. Although this is at the end of the bracket, you still expand it in the usual way. D times 2n, d times 1 is equal to 4n divided by 2, that's 2n, half of 4 is 2, brackets 2a plus nd minus d. Okay. Now at this point I can see that I've got n's on both sides, so I can cancel those n's out, essentially dividing by n on both sides. And then I'm going to get 2a plus 2n d. I'm writing. I thought there was a bump in my writing. That's what it is. 2a plus 2n d minus d is equal to 2 lots of all of this. So 2 times 2a is 4a. 2 times n times d is 2nd. 2 times by subtract d is 2d. Okay. Now the next bit that I can see is I've got 2nd on both sides, so take away 2nd from both sides, and they will cancel each other out. So 2a minus d is equal to 4a minus 2d. From there I need to take away 2a, take away 2a from both sides, and I'm going to get minus d is equal to 2a minus 2d, and then add 2d to both sides. And I get d is equal to 2a, which gives me half both sides. A is equal to a half of d. Just half both sides. A is equal to a half of d. I hope that makes sense. I've gone a little bit obviously onto the next question, but that's what you need to do. You need to use the formulas on the formula sheets. You might be able to remember that, you might not, but it's there. In the same way your calculator is there, check it. You know, make sure what you're doing is right, is correct. Okay. What I'll do now is I'll go through that question from last time, and I want to show you a question to think about for next time. So this is the question that was in the thumbnail, which is not a straightforward vector question, let me tell you. So it is tricky, it is difficult, and it's unusual. That's why it's difficult, basically, because it's not a standard one. It's not show that these points lie in a straight line, show that these vectors are parallel. It's not one of those. For this question, we've got to find and simplify an expression in terms of a and b for O to P. Now, O to P, we don't know. We know these lines cross, so we know the diagonals OC and AB of the trapezium intersect at P. And we've got triangles here, and you could think about maybe looking at similar triangles, and that might work. It might do. The only issue is you don't have angles, so you know it's a bit trickier. But what you do know is you know that this triangle is congruent to this triangle, and so you might be able to use congruent triangles to do it. That's not the approach that I am going to take now, but that it might be possible. So first things first, check everything is on the diagram. O to A is 2A, O to B is 5B, A to C is 3B. That's on the diagram. We know the diagonals intersect here. Find and simplify an expression. Yep, show my working clearly. Now, okay, so what I do know, I can work out A to B, and I can do O to A. So I could go O to A and then A to P. I could also, I can work out O to C, and I could then, there's got to be some fraction, some multiple of O to C gives me O to P. So some multiple of that. Right, so I could start to formulate that in terms of how that would work. Let's start with the easier one, O to C. So O to C is 2A plus 3B. Okay, so O to P must be, and you can use any letters you want to do this, but some multiple of that. So I'm going to go with, let's go with N. So N lots of 2A plus 3B, where obviously N has got to be less than 1, because otherwise it's just going to go, if it's 1 it's the whole way, if if n is greater than 1, it's going to be further, so it's got to be less than 1. Okay, so that's O to P in terms of some multiple of O to C. Now I've said I could do it a different way. I could do O to A and A to some fraction of A to B. So O to P is also O to A plus, let's say, M lots of A to B would be right. So I'm not sure why I put that in brackets, it doesn't matter, but I'm just supposed to separate out the M there. So O to A, so O to A is 2A plus M lots of A to B. A to B is minus 2A plus 5B. And we get this. Now that means these two things must be equal to each other. So I've got that, and I could expand this out. I will expand out in a second. N lots of 2A plus 3B is equal to 2A plus M lots of minus 2A plus 5B. Now what I need to do here is I need to work out N and M, and well, if you've got two variables, what you need to have is two equations. Now what I can do is I can make two equations by looking at A's and B's, because A's and B's are different vectors and they've got to be, I've got to have the same, well, I've got to have, if they're equal, I've got to have the same amounts of A's and B's. So I could start comparing my A's and comparing my B's on both sides. What I first of all need to do is expand this. So I'm going to get 2AN plus 3BN is equal to 2A plus, and this is going to actually be subtract 2A times by M, and then plus 5B times by M. Now what we can do essentially here is make two equations. So I've got, if I look at my A coordinates, I've got, that's A and this is A, and then I've also got, I'll do it in a different coloured pen, this is B parts and this is B. So I'm basically comparing those, and the easiest one is the B parts first of all. So 3BN is equal to, has to be equal to 5BM. Okay, now what multiple of 3b do I have to make it into 5b, essentially? What do I have to times that by? So I can divide both sides by m, and I get 3b times by n over m is 5b. And you could cancel out the b's if you want. Cancel out my vectors, my b's. I get 3 times by n over m is 5. That's not looking too nice. I'm going to multiply out back up by the m, so 3n is equal to 5m. So I just need some kind of substitution I can make, so I just need n equals or m equals. So divide by 3 on both sides, I get n is 5 over 3m. I've done this a different way around to the way I did it originally, but that's fine. N is 5/3 m. Now I've got that, then I can substitute that into equating my a terms here. So I'm going to write those out. I'm going to equate it first of all. So 2an is equal to 2a minus, or plus the negative, 2am. Now what I'm going to do, I'm going to replace n with 5/3 of m. So 2a times by 5/3 of m is equal to 2a minus 2am, and that will give me 2a times by 5, or 2 times 5/3 is 10/3, so I get 10/3 of a times by m is equal to 2a minus 2am. Add 2a to both sides, or 2am to both sides, excuse me, Now 2am plus 10/3 of m. Now 2 in terms of thirds is 6/3, so I'm going to end up with 16/3 am is equal to 2a. Now I can cancel out the a's on both sides at this point, so 16/3 of m is equal to 2. So then I need to multiply by 3 and divide by 16. So 3 times 2 is 6, so I end up with 6/16, which is 3/8. And now I've got my m. Then all I need to do is substitute that into my original up here. And so it might have been easier to work out n, because then you should have times it by those two things. I don't have to do the addition, but it doesn't matter. So I'm going to go back up here, and I've got 2a plus 3/8 negative 2a plus 5b, and we get 2a, negative 2 times by 3 is negative 6/8a, 3/8 times by 5, 3 times 5 is 15, so you get 15/8b. We're nearly done. So I've got to do 2 take away 6/8. Well, 2 out of 8 would be 16 out of 8. 16 take away 6 is 10 out of 8a plus 15 out of 8b. And if you did want to simplify it, simplify this first one, can't simplify the second one. So you get 5/4a. It says find and simplify, so we have to simplify it. 5/4a plus 15/8b. And that's the answer. So even though it doesn't look like it, you do have two equations with this, because you've got your a equation and you've got your b equation. That's all your terms with a in, and that's all your terms with b in. So you can just set those equal to each other, because the whole thing has to be equal, and you've got to have the same amounts of a and the same amount of b. Okay, right, I hope I explained that okay and well enough. Any questions, as always, put them in the chat, and I will answer them, get back to them, or address them in the next video. But I will make sure I answer those for you. Please like the video if this has been useful, because that lets me know it's been useful and actually that it's worth doing. Use the recommended websites. Obviously watching these videos is good and useful and will help, but you will need to be doing your own work as well to focus on what you need to focus on. So use those websites that I've put on there, Maths Genie and so on. We don't have long now to go. I believe it's 39 days it says on there. Yeah, less than 40 days. So that's nearly a month left, basically. We've got about just over a week and a month left. Yeah, and also, you know, there is that buy me a coffee down there if you did want to support the channel in that way. Thank you for your support, and thank you for watching these videos. Hopefully they're useful. I'm sure they will be. So yeah, thank you, and I will just put up the next question. So this is the question for next time to think about. So it's this question: how would you solve this? Now this is a question I come up with myself. It's not a question I found from a paper, but this is a question that could be on a paper. This is a question that only requires all the stuff that you know how to do. So I don't see any reason why this couldn't be on a paper. Okay, have a think about that one. I will put it in the thumbnail for next time as well. And yeah, I'll see you next week. Thank you, and bye bye.